Okay, okay. Magandang hapon. Good afternoon, everyone. Good afternoon to everyone who is here live. Good afternoon. Hopefully, you are chilling in the comfort of your home. Hopefully, dili ka muna initan sa rat. Hopefully, you are safe and sound in the comfort of your home, or at least somewhere that is cool over the next 2 hours. Again, over the next 2 hours that I will be broadcasting and teaching you concepts and lessons from Science 9 and Araling Panlipunan 9. Okay, so I hope you are with me in the chat. I hope you're with me in the comment section. You can message me now at your group chats, everyone. Maraming salamat. Kung nandyan, if you are watching me right now and you're live, I'm thanking you for being with me today. Okay, so today is the good day of our Lord, April 16, 2024. So we will be continuing our lessons. Today on Science 9, we will be talking about more specific. We'll go a little bit more mathematical on our approach now in kinematics in describing our projectiles by using the kinematic equations that we have discussed a little bit earlier from last week, around Thursday. Now, we will be Thursday naman, Friday. Sa itong mga na hisgutan pag Friday. And then, on Araling Panlipunan 9, meron tayong bagong sektor na pag-uusapan, ang sektor ng industriya. But for now, we'll be tackling Science 9, and we'll be talking about the height and range of a projectile. If you haven't seen your modules, I hope that you have get a hold of it. Nakakopya na kamo, na-download na ninyo ang picture versions ng aton modules sa group chat. Okay? So, am I heard? Am I getting watched by? Napapanood ba ako ng aking mga estudyante? I'm checking in on your... Okay. Okay. So, we're good. We're good. Hopefully we're good in our time together. Okay? Now, okay. Sige. So, we will start with our Science 9. Hopefully you are ready. Hopefully you're chilling at the comfort of your home or somewhere cold as you get your internet connection. Okay? So, cooler. So, let's start first. So, last time we have talked about projectile motion. We have described projectile motion. And we have used some terminologies like the trajectory of our projectile, which is the object that is moving in projectile motion. Now, we will look at projectile motion a little bit more mathematical today. Okay? So, it would be nice if you would somehow treat it as a combination of science and math. Wow, very formidable. Nakakagulat. Science at math pinagsama. Pero it will be much easier. The concept of science, the concept of projectile motion will be much easier if we think about it mathematically. Okay? Masayon siya, masabtan kung ara na ang math na nagpaluyo sa iyo. Okay? So, let's proceed. Let's start with our discussion for today. Okay? Now. Naka-studio mode pa lang. Now. So, let's start first with the two most important things or most important values when we are talking about projectile motion and describing a projectile. It is the height and the range of the projectile. Okay? So this one's actually mentioned yesterday. Height is the maximum distance from in the vertical direction. So kumbaga, gaano kataas ang naabot sang aton projectile. And then the range is gaano kalayo. How far forward did our projectile run? Gaano kalayo paatubang ang aton, ang gijagan sang aton projectile. Now, again, so here's a different perspective, or I think better perspective kung aton hunaw-naon ang projectile motion. Ang projectile motion ko no is the combination of horizontal motion with constant velocity and vertical motion with constant acceleration. Okay, let's break that down, okay? So, projectile motion, combination siya sang duha ka motion. Just like what we have mentioned yesterday. It is horizontal motion and vertical motion. But we're now adding clear descriptions. First, in the horizontal motion, we have a constant velocity, meaning it doesn't change its velocity. As the projectile is flying through the air, moving along its trajectory, nagjagan siya, naglipad siya, parehas ang iyang velocity on the horizontal axis sa pahigda. Meanwhile, when we are talking about vertical motion sa iya paigbaw ubos, we have a constant acceleration. Wa kita magsulti, magbago ang iyang velocity. It is because we have a constant acceleration. Acceleration due to what? Acceleration due to gravity. Gravity sang Earth ang hinungnan because of the gravity of the Earth. Yun yung medyo, joking, but it is the reality. We have vertical motion with constant acceleration because of the gravitational force of the Earth. Now, so on the horizontal component, again, the jumping. Okay, on the horizontal component, we have an acceleration equal to 0. In ideal conditions, we have an acceleration equal to 0. Wa kitay acceleration on the horizontal axis. Yeah, let's a little bit zoomed in. Because wa kitay acceleration on the horizontal axis, therefore we won't have any change in velocity. It will remain as constant. Here it is. Velocity of projectiles along the horizontal component sa pahigda, it is constant. Now, if we look at it on the vertical, we have a constant acceleration. However, may ara katay constant acceleration due to the gravity of objects on Earth because it is attracted to Earth. Okay? So, now, all of these the equations between, so now our kinematic equations will look like this because of that. So, let me show you, okay? So, let me show you. I have somehow linked them in this way. So, let me show it to you. Okay, so, projectile motion, again, we have projectile motion. It is a combination of the horizontal, hopefully maklaro, ma-erase, horizontal and vertical motion. Now, when we're talking about positions, in horizontal motion, we use the variable x, and in vertical motion, we use the variable y. When we're talking about their initial positions on the horizontal, we use xo. On the initial, for the vertical, we use yo. Now, when we're talking about velocities, the initial velocity of an object, when we're talking about the initial velocity of the object, aton gilabay nga object, sa vertical naman, horizontal, we use v sub ox or v sub ox, vox. And then, when we're talking about vertical, sorry, I got switched. Meron vertical, once atong hisgutan ang vertical initial velocity, initial ver initial vertical velocity sang aton object, we're talking about VOY. Now, ato naman ano, ato naman tan-awon sa aton final velocities. Most often, we have Vx and Vy for horizontal and vertical respectively. Now, let's look at their accelerations. Now, take note, wag magbabaliktad. Wag nyong this is one of the more important ones once we're talking about projectile motion. In the horizontal aspect, Ax is always equal to 0. We are talking about constant velocity. And acceleration is a change in velocity. So kung constant siya, there is no change. If there is no change, then acceleration is equal to 0. That's why Ax, or horizontal acceleration, is equal to 0. Okay? Remember that one. Next, once we're talking about vertical motion, basta vertical motion naman ang aton hisgutan, dili lang siya basta kung nanong gihata. It is a constant naman. Acceleration in the y direction in vertical is designated as g, or a sub g. That has a value of negative 9.8 meters per second, or as would like to explain it here, 9.8 meters per second per second. So every time our velocity in vertical every second, our vertical velocity will change by 9.8 meters per second. Okay? Kada segundo, magbago ang velocity sang aton object by negative 9.8 meters per second. Or, maibanan, sang 9.8 meters per second, pwede lang nga mag-accelerate, magkakusog 9.8 meters per second paubos. Okay? Now the binding concept, one of my mental tricks on this one, the binding, ang ilang middle point, hain sila magtagbo. The common thing in both horizontal and vertical aspects of projectile motion is your time. Both of them require time. And dira sila mag-upod. The kinematic equations that we have right here, the kinematic equations like on the horizontal and the vertical aspect, both of them require time. Most of them require time. Later on, may gamay lang na modifications, but the time binds them together, connects them. The horizontal aspect, the horizontal variables, ang equations na gikan sa horizontal, makonekta naton padung sa vertical using time. So most often, kinanglan gayod, makaibaw kita sang time. Amoy na ang aton hinumduman. Now, let's go back here. So, again, we have our equations na aton siyang bag-uhon. Now, here's the fun part. Okay? So, all of this are okay. Now, so we'll have our simple example or simple thing. Now, let's assume we have a object, a ball, that leaves at an initial position, at the very origin. And it is a ball leaving a thrower's hand. Bola nga gilabay, simple lang. Bola nga gilabay nga atong subayon. Okay naman? Give me a few seconds, nawaha na ako na ang akon tawag sini. Ako na eraser. Anyway, now, Let's assume we have a ball leaving its initial position 0. At time is in 0 seconds. Meaning, magsugod pa lang, ilabay pa lang, the object will start in its motion. Now, two-dimensional motion po. We're talking about projectile motion is a two-dimensional motion, meaning we are looking at not just on the x-axis, but also in the y-axis. So, it can be described two ways, just like how we did it. It can be described in two ways. How far, it can be described horizontally, meaning how far. If ang bulag aton gilabay paatubangan, gaano kalayo forward ang iyang maabot. And or vertically, how high. Sa aton paglabay, gaano kataas ang iyang maabot. How high will it go? Now, these terms, if we are talking about horizontal, if we are talking about horizontal distance, gaano ka abante ang nalabayan sang aton bola, we're talking about its range. Once we're talking about how high an object has reached, we're talking about its height. The height and range of an object reaches is dependent on these two factors. First, how fast it leaves its initial position. Nanong iyang kapaspason, how fast, meaning we're talking about its initial velocity. And we're talking about the angle when we're talking about the angle at which it leaves from its initial position. Okay, now, both of these things, these two factors, how fast is its initial velocity and its angle from original position, amo ang aton kinanglan na masubay. Now, what is this? What is this diagram? And bakit meron ako nakikitang sin at cos? Okay, let me break down it for you. So, once we are talking about two-dimensional motion, we have to break down a velocity, a vector, to its component vectors. We are talking about initial velocity with its component vectors. Okay, so let me draw this one for you let me draw this one for you para makita natin. Here's the diagram that I'll be making. You can picture that, but I'll be drawing it live for you. Okay, so here's okay. So let's put it before I switch my camera. Okay, so okay, and then let's use this. Okay, board. Okay, so we have our x-axis at the horizontal and y-axis on the vertical. Now, if we have a ball leaving from its original position, let's say we have it right here. We have it right here. Once we throw it at an angle, or even in the horizontal, actually, later, ipapakita na ko sa inyo. We throw it in the horizontal. Whether it is type 1 or type 2, it will eventually have components. But let's focus on type 2, angle launch projectiles. Now, once we throw it at an angle, its velocity, so here is our initial velocity. Let's put it as red. That siyang iyang initial velocity. Okay? That is its initial velocity. Now, to break it down to its component component vectors, we have to look at its x component. Hopefully, I'll separate this one so that it will be legible right here. Did I get this one right? Okay. And then, okay, I just moved it, scooched it a little bit bottom para makita natin. But should be right here at the X, okay? And also, we have your Y component. So let me put that here. And then, that's your V. Uh, V, and this one is okay. Now, so basically, you have your vector V. You have your vector that is in here. You have a vector that is in velocity, meaning vector siya, vector quantity. We have magnitude and direction. Now, we have our com- component vectors, which is we have our component vectors v x vx plus v v y. Okay, it's more like this. If you want to move an object, let's say for example, if you want to move a table, let's say you're dragging a table across the let's say across the classroom. If you're just pushing it forward, if you're just pushing it forward in this direction, it would just move here. But if another person would push you sideways, the general direction would not be forward or to the right, but a combination of these two. Now, a combination of these two forces or these two motions would look something like this. Okay? That's why we can break down on the flip side kung balihon naton, sige balikan na ha. Kung iduso na ako ng lingkuranan, paatubangan, padung diri, ang iyang lihok, ang iyang velocity, padung dito. Kung may usa palat ka tawo nga magduso sang imong gituso nga lamesa, to the right naman, dili lang kay to the right lang ang iyang lihok. It will be a combination. Combination sagol sang duha. Dili siya forward, dili lang siya basta forward, dili lang siya basta to the right. It will be to the front, it will be to the front and to the right at the same time. Magpa-takilid. Okay? Now, this is the flip side. Pwede na ito nabalihon. Kung may akitay nakitaan nga naglihok na pagtakilid, pwede naton siyang subayon pabalik sa iyang mga forces, iyang velocities nga horizontal from left to right kag sang iya vertical velocities gikan sa ubos padung paigbaw. That's why we have here. That's why you have your this one. Now, sir, paano kung ito lang ang alam ko? What if paano kung this is the only one that I know? Its initial velocity. I know the I know the angle and at which I launch that ball or I've moved that object relative to the horizontal. How do I solve for it? Diyan na po papasok ang math concept natin, ang ating trigonometric functions. If we have a value right here, Vx, or sige, let's say, iabotang natin, saktuon natin, let's keep it consistent with the material that we have. Let's have VO, okay? Vx, or the initial horizontal velocity would be VO multiplied by cosine cosine theta. So, ano naman ang cosine? That is a trigonometric function. Okay? So, once you hit, once you have your, in your calculator, okay? So, let me show. Hopefully, I'm alive. Okay, opening up my cell phone. Okay, board and phone. Oh no. Oh yes. Okay, okay. Okay. Now, so we have here. So hopefully you can. Oh, hello, hello, my love. Okay, so wait lang. Baka mga wait lang, ha? Let me check. Oh my goodness. Replyan lang muna para hindi magtama. Okay, so right now we have your velocity. Now, cosine. I have already sent you this app right here. This is uh, Hyper scientific calculator app. If you don't have if you don't have dedicated scientific calculators, you can use your cell phone. But then again, I noted at our we can use this during our regular classes, but in the periodical exam, you should be using dedicated scientific calculators. Okay, so we're talking about, let's say we have 45. Let's have, okay. So if we have cosine, automatic, it's just around, it's in degrees. Okay. Let's say cosine 45 is that. Okay? So you would get this a little bit of a value. Labain na. But later on, magamit natin na. Okay, cosine 45, uh, cosine 60, cosine 60, uh, cosine, ano pa kaya na, um, 60, 45, 30, 30. Yeah, those are your special values. But basically, we're looking at the angle at which it is thrown in degrees. In degrees. Hindi po radian sa degrees. So, we will be using that later. Okay? So, if we have an initial velocity, kay bao kita sining nga velocity, and kay bao kita sang angle of release. So basically, from our conditions earlier, how fast it leaves its initial position, its initial velocity, initial velocity, and the angle at which it leaves its position, the theta. When we're talking about theta, once we're talking about that, once we know that quantities, we can employ this. Okay? Vx is equal to VO cosine theta. Cosine ha, cosine, cos. And then on the y-axis, Vy, Vy is equal to VO, VO sine theta. So you can now break down your equations. You can now use the kinematic equations that we know right here. We can use now the kinematic equations that we know using these values right here. Kumbaga, kwaon nato nini, and then later on, we'll have it right here. But the danger is here. Mas nindot nga, ang naibawan nimo VO cosine, ang imo naibawan is the initial velocity, and then, later ka na lang magano. Kumbaga, dili lang nimo, the calculations start from this one. Okay? From the initial velocity itself. Para ang rounding errors, kumbaga dili naton mautod ang mga decimal points, ang mga values nga ara sa luyo pa sang aton decimal point. Okay? So continuous siya dapat. So kani siya magamit naton, kani siya diri magamit na. Okay? Now, so that is now how we break it down. Nasaan na pa ako? Mm. Facebook Facebook viewers are watching a different version. Okay. Okay. So for the phone screen. Okay. Now we know the initial conditions. So these are this is what I have been babbling about for a little bit now. VOX or the initial horizontal velocity is just the initial velocity multiplied by cosine theta. And the initial horizontal velocity is initial velocity multiplied by sine theta. Okay? Now, that's all of. So now your equations become like this. So your x becomes VO cosine theta t, and then y becomes this one. Okay? So, pakita na ko. How come paano po ito nangyari? What just happened? What just happened? Okay? So, once again, once again, let's have our derivation. How did that equations came out? Okay? So, my goodness. Wala talaga yung ano. Okay? Give me a few seconds. Let's start with the initial conditions first. Okay? On the horizontal axis, okay, board and face. Now, on the horizontal axis, ano ba yan? On the horizontal axis, let's start with our kinematic equation number. This one. Let's start with our kinematic equation right here. So, delta x is equal to VO x t. Let me use a finer. Okay, actually, let me use a finer one so that we can. Okay, so Vx is equal to VOXT plus 1 half AT squared. That's on our horizontal component of our projectile motion. Now, once again, remember, in the horizontal component of our projectile motion, AX, or horizontal acceleration is equal to 0. Any number multiplied to 0 will become 0. So, all of this, in 1 half AT squared, it will become 0 because it is multiplied to A. So, all of these will not continue. So, padayon kita. AX, so akong butangan sa intermediary ha, VOXT plus 1 half 0 T squared. So 0 times 1 half, 0. 0 times t squared, it's 0. So it will become just VOXT. Now, let's put what is VOXT. From our previous derivation, from here, we know that VO, okay, from our previous derivation, sige, important base. From here, we know that from here we know that Vx is equal to VO cosine theta. So, or let's put it right. VOX and then this one is VO1. Okay? Linisin. VO. Let's make it consistent. VO. Let's make it conceptually consistent. Cross. Okay? Para ano tayo? Para hindi na magkandalit ulit. VO. Then VOX. And then this one. VO. Okay? Okay? We're good? So this one. So from this derivation, we know that VOX is equal to VO cosine theta. Now, let's flip it over. Let's change VOX, VO, VOX, VOX. I'll put it right and here para makita natin. Okay? So, well, let's change VOXT. Let's change it to VO cosine or sine. It will be cosine. Cos theta multiplied by t. So delta x. Okay? That is now your new equation. Now, let's have on a different one. Mari kita dire. Let's have on the y. Let's use also the first kinematic. Let's also use the first kinematic equation. Okay, so again, we're talking about on the y-axis, that would be delta y. V O Y. Oh no, I used the red. Sige lang. Red ko na lang po. Sa likod ng ginamit ko ay green. But later on, ang gagamitin ko dito sa vertical. Ayun pa. Medyo mas pino po kasi. Okay? Para mapaiga. Gamitin mo na yung green. Okay? So, delta. Oh no. Oh no. Okay. Ayaw niya talaga ipagamit ng green. So, we'll go to the red. Pula po. Gusto po. Ayun ang ano. So, delta y. Okay, let's put it right here. Delta y is equal to V O Y T multiplied by T plus 1 half T squared. We know the value of G. It will not be 0. It will be negative 9.8 meters per second. Let's put it that way, anay. Biyaan lang anay natin. Next, we now to change VOY to in terms of VO or initial velocity. We will change that. We will use delta y is equal to VO sine theta multiplied by t plus 1 half 1 t. Ito na siya. So, that term, ang VOY naton, gipulihan naton sa VO sine theta because of this derivation right here. Okay? VOY is equal to VO sine theta. So, we have here your, and we have now the other, and then we have now your next line here. We have now for the velocities. We have now your velocities. Vx is equal to V cosine theta. That's given from our derivation. And then it would just be a simple drop-in replacement. VOY will just be VO sine theta minus GT. Why? Bakit siya naging, saan ang pinanggalingan ng mga let's go back to the board. Okay, so all of this, we will be using on both sides. We will be using the third kinematic equation. The third kinematic equation looks like this: Vx is equal to Vox plus AT. Since on the horizontal acceleration is zero, it will be removed. Mawa na lang siya. And then Vx is equal to, Vox is still again VO cosine theta. That's now your Vx. Next, we have your on the this one's on the horizontal. Sorry if I misspoke. This one is on the horizontal. Now on the other side, we have your vertical. Vy is equal to Voy plus GT. Now, T, your VOY would just be replaced by VO sine theta plus GT. That's how we arrived. That's how we arrived at these equations right here. Okay? So, mahaba-haba pa tong usapan. So these are your equations now na pwede nato. So, actually, diri pa lang, it is a jump start pa lang siya sa aton mga gamiton. Now, sir, you have mentioned, sir, atong kalina, atong height kag range. Paano calculate? Ano man naman sinapag-calculate, sir? Now, we will use these previous, we will use these equations to find the height and the range of our projectiles. Gaano kalayo gaano kataas, kag gaano kalayo ang maabtan sang aton mga projectiles. So, well, let's move along. Let me take a few moments to scroll to our. So, we'll be talking about, so most of the ang isa sa mga pinaka gamitan is ang pinaka ano ho naton is ang K type 2 projectiles, angle launch projectiles. Now, we have our component vectors, projectile velocity in its x and y components. Again, if we have an initial vertical initial velocity, it can be broken down to its horizontal and vertical components. Now, here in the figure, di lang siya klaro, but ang iyang opening sang iyang parabola, it's long. Depende ina siya sa aton. So the trajectory of our body that is moving is in a parabola, or it is parabolic. The figure above shows the position of the body is ascending since the vertical velocity of component of the velocity VOY is still going up. So let me draw that. Let me draw that for you. Give me a few seconds to do so. Okay. Now, okay. Okay. So, if we have a ball getting thrown, sige, gagamitin na natin yung green. Yung green na natin gagamitin. Right here. If we have a ball getting thrown up, we have your initial velocity. It has its component vectors. We have your horizontal velocity, which is your Vox. And then we have your you have your initial initial vertical velocity VOY. Now, its path will move, its path will be a little bit, it will be a parabola. Its path will be a parabola. Let me approximate that. That. That's my best, that's my best representation of a parabola. Okay? And then let's look at other points. Okay? So as it goes up, one, two, and then right here at three, let's put it at point A, B, C, and then kuhaon lang nato ng paubos, D, E, and then D, E, okay? So, halos parehas ini siya sa atong gidrawing last time. Sang parehas sa gidrawing natin last time. We have your, how far is it? Velocity remaining the same. VOX, VOX, gyapon natin, VOX, gyapon natin. All throughout all throughout the time, because we don't have acceleration. Initial velocity is final and final velocity are the same. Ingay. Initial velocity and final velocity are the same because it is in the horizontal axis, it is a constant. It is with no acceleration. No, zero acceleration. Now, on the flip side, on the vertical naman, we have your initial vertical velocity, but as it goes up, it it slows down. So may ara kitay initial velocity right here, magkagamay, at here, wala na. And then later on, magkaubos, magkalaba, and then another yapon nga. So going up, it is going up, but it is slowing down. Padung siya, paigbaw, pero nagkahinay siya. Nga nagkahinay man, kay may ara katay acceleration due to gravity nga negative paubos ang ato na no, negative 9.8 meters per second. Meaning every second nga nagjagan siya, every second na naglupad siya, maibanan o mabira siya paubos at a speed of 9.8 meters per second. Now, oh hello. Maraming hindi ko na na-check kung sino yung mga nagla-like, sino mga napapadaan sa akin. Most often sa Facebook, maraming napapadaan sa Facebook dahil naka-public tayo. Okay. So, now, now, once na we're talking about here, we have your acceleration due to gravity that is still always pointing downward at a negative 9.8 meters per second squared. Okay, now, at maximum height, at point C, your velocity, sige, your velocity is equal, your Vy right here is equal to 0. At point C, your Vy is equal to 0. And then your Y is equal to the H. H is now what we refer to as the height. Height. Or, sa aton sa aton description last time, it's your maximum height. Amo ang pinakataas na iyang na abtan. Okay? Y is now, at this point right here, at point C, Y is equal to H. Now, Same gyapon. Right here. So, ako lang siyang gi-drawing right here. And then, the time it took, from this point right here, sige, butang natin. Time it takes, tak, tak, the time it takes from here to right here at point C is, we'll call that as small letter t. Small letter t ha? Later, small letter t ang gikan diri padong sa point C. Okay? Time ang aton gi-sukod diri. Now, so let's use that in our equations. So let's use that at our equations. Now, kung ibutang natin siya sa y component sa aton velocity, we'll see that Vy is equal to Vo sine theta minus Gt is equal to 0. Okay? So, ibutang natin siya dire. So, ibutang natin. Kaya ba ka that okay, let me show that again. So, kibaw kita na at point C, ang atong gusto may bawaan, again, this will tie up. One of the important things that we need to know is the time. Okay? So, kibaw kita sang iyang initial velocity. We know that its initial velocity is Vo sine theta. We know that because we know its initial velocity, and its angle of release. Plus, minus, g, we have your acceleration due to gravity. And then, this one right here, mo na siyang dili natin nahibawan. Time. Okay? Next, we have your Vy right here. At point C, amay natin gamiton. At point C, Vy is equal to 0. Vy is equal to 0. Now, let's look at right here. So, kung Vy is equal to 0, 0 is equal to Vo sine theta minus Gt. Okay? Wa ba? Now, ibalhin natin si G para ma-isolate natin. This one right here, we need to find the T, small letter T. So, what do? We move it to the other side. We isolate it. Now, you know me, I know transposition, but ipakita na ako. 0 plus gt is equal to Vo sine theta minus gt plus gt. Positive, minus, plus, minus, both terms, positive, negative, this one will get cancelled. Mawa na siya. It will become 0. So this one plus gt is equal to Vo sine theta. And then, we divide both sides by g. Jumping, kung nakita sa space diri, t will become Vo sine theta divided by g. That's why we have your time right here. And then we will use this to replace onto another formula. Okay? That's why we got this value. We got this equation right here. Small letter t, or time it took to reach the peak. Small letter t, ang time niya ihap naton para makaabot ang aton projectile to its highest point. Okay? Small letter t ang aton gamiton. Later on, may lain-lat nga t nga gamiton. Now, this small letter t is VO sine theta all over G. Now, aton siyang ipuli sa aton equations. Now, how do we get the maximum height? Now, we'll use the first, we'll use the kinematic equation na aton gigamit kadina right here. So, sakto ra ari pa sa aton board. Okay, we'll use this one right here as our benchmark for aton gamiton nga equation. Okay? So, let's continue this one. So, ang aton gigamit, ang aton nakuha kalina is what lang naton? T, small letter t is equal to VO sine theta all over G. So, this one, gamiton naton. This one, okay. So, we'll put equation 1 into equation 2. Isod naton siya diri. Ang mga t, pulihan naton sa VO sine theta. So, delta y is equal to, again, VO sine theta. Next, ipuli natin nila siya. So, mahimo siya VO sine theta all over G plus this one. 1 half G, G, then ang T squared, VO sine theta all over T, all of it squared. Sumobra na sa board. Okay? Now, after that, let's distribute. Ano siya? So, VO sine squared, let's put it as VO squared sine squared theta all over G. Numerator to numerator man. So, ang iyang numerator diri is 1. So, numerator, VO sine squared, VO squared sine squared theta all over G plus this one, ganyan siya. Okay? So, now, aton siya, this one right here, aton siya squared, 1 half G VO squared sine theta all over G squared. Now, G divided by G squared is equal to just 1 over G. So, makancel sa dire, ining G nini mawala. So, may siyang 1 over 1 half G O squared sine squared theta all over this one right here naman sa pika, VO sine squared theta all over. Di pala to. Mali. Ah, okay. Okay. I know. Okay, G is, this one's negative. Okay. Now, once we combine that, we have your G minus 2G. Dapat magda-double to. So, ang aton delta Y, pulihan lang natin siya, mahimong isa diri siyang delta Y. We can conveniently replace that with the letter H. By simplifying this, later on, once we simplify this, we arrive at this particular equation. Once we simplify this, we can now have the simplified equation. H is equal to VO squared sine squared theta all over 2G. Muna na siya ang aton gamiton nga value. Okay? Okay. So, overtime na po ako. So, this one, we have an overtime. Nag-ano po tayo. Nag-overtime tayo ng 3 minutes para sa science. So, later on, so we have derived the equation to calculate for the height of a projectile thrown at an angle. That is h. So this one right here, h is equal to h is equal to h is equal to VO squared sine squared theta all over 2G. Amo na siya ang aton gamiton. Now, amo na siya ang aton gamiton. Then, tomorrow we'll be talking about, hopefully tomorrow, we're still awaiting for announcements. Hopefully by tomorrow, we can talk about the range. How far forward can our projectile go? Okay? And then after that, after the derivation, let's apply it to a problem mismo. Because clearly, medyo nakakalito siya kapag pinag-usapan lang natin siya pure math. Let's put it in a problem and then let's see how it works. Okay? So, if there are any questions, I hope that you can chat them. Iswat, i-chat sa aton group chat. You can PM me, you can DM me if you are a little bit shy or a bit super shy about it. And later on, we'll be discussing more of it. Kumbaga, i-explain pa naman na siya further to you. Okay? So, after a quick break, I will be back at around 4:10, and then later on we'll have Araling Panlipunan 9. Okay? Ang ating susunod na pag-uusapan sa Araling Panlipunan 9 ay ang sektor ng industriya. Bagong sektor, bagong matututunan. Yun na lamang po. So that's it for Science 9. I hope you learned something, or at least you get a glimpse of what we are about to do in the next days. Okay, so that's all for today for Science 9. I hope you can tune back in tomorrow. Okay, so that's for Science 9. I will be back in a little bit in 5 minutes for Araling Panlipunan. Bye for now. Bye for now.